So in trying to find restrictions on rational functions, it helps first to recognize what a rational function is. A rational function is two polynomials divided by each other. So x plus 2 over x minus 3 is an example of a rational function. Notice on the top I have a linear function, x plus 2, which is a polynomial, and x minus 3 in the denominator, which is again linear, which is a polynomial. So when I'm trying to find the restrictions, the only restrictions that we'll come up with on a rational function is in the denominator, because if you look at the big picture, I have division here, and we know that we can't divide by 0. So whatever is on the bottom of the fraction cannot equal 0. So to identify what the restrictions are, we can take the denominator, set it equal to 0, and solve. This will tell us what value for x would cause a restriction. So in this case, we're just solving the linear equation x minus 3 equals 0. So if I add 3 to both sides, I get x is equal to 3. This tells me then that the restriction on this rational function is x cannot equal to 3. If x is 3, then I end up dividing by 0, which causes the world to explode. So another example. Say I have f of x equals x squared plus 5x minus 7 divided by, let's make that x squared. Sorry about that. X squared plus 3x plus 2. Again, this is rational. I have a polynomial divided by a polynomial. So the restrictions of this will come from the values of x that will make the denominator 0. So I'll come off to the side, set the denominator equal to 0. And now, in the first example, I had a linear equation, so we just had to add 3. In this example, I have a quadratic. So recall all the different ways to solve a quadratic. We have the quadratic formula, we could complete the square, we could factor. Any of those options are good options. I see that this one is factorable. To get 2, I would multiply 2 times 1, and if I add 2 together, I get 3. So this factors into x plus 2 times x plus 1. And now the 0 product property comes into play. Since I have this in factored form and it's set equal to 0, I can set each factor equal to 0. Now we've reduced the quadratic to 2 linear equations. Now I can subtract 2 from both sides, subtract 1 from both sides, and I get the restrictions on this rational function are that x cannot equal negative 2 and x cannot equal negative 1. So this one ends up having 2. Let's do one more example. So I have 2x plus 5 over 3x. Again, just 2 linear equations divided by each other, giving us a rational function. And I want to find the restrictions. So again, I'll take the denominator and set it equal to 0. So to solve, divide both sides by 3. And in this case, I get the restriction that x cannot be equal to 0.